Hello, my name is Vendrila Das. In this presentation, I will explain my project on future location prediction using machine learning. The goal of this project is to analyze historical movement data and estimate where an object or person is likely to move next. Today, location data is continuously generated through smartphone, GPS, vehicle, and various IoT systems. This dataset contains geographic coordinate along with timestamps showing how objects move from one place to another. If we analyze such movement pattern carefully, we can train our machine learning model that learn how location change over time. Once the model learns this pattern, it can estimate the next location based on current movement information. For building this system, I use the platform Dataiku Data Science Studio, which allow us to perform data preparation, feature engineering, machine learning modeling, and visualization in a structured workflow environment. In this project, I build a complete pipeline that starts with raw GPS data and ends with a predicted geographic location plotted on a map. Now, understanding the dataset. Before building any ML model, it is important to understand the dataset we are working with. The dataset used in this project contains movement record of a device or object. Each row in the dataset represents a single movement event from one coordinate to another. The main column in the dataset are ID, a unique identifier for each record, event time start, the time when movement began, event time end, the time when movement ended, latitude start, the starting latitude, the starting longitude, lat end, the latitude of the destination location, and longitude end, the longitude of the destination location. So, if we interpret a single row, it means that the object started moving from a certain coordinate and after a certain time, it reached another coordinate. By collecting many such rows, we obtain a movement history of the object. Our objective is to train a model that learn this movement pattern and predict the future latitude and longitude. Why data preparation is important? Although the dataset already contains useful information like coordinate, timestamp, machine learning model is usually performed better when additional informative features are created. This process is feature engineering. The original dataset only contained raw information about coordinate and timestamp. However, these values alone may not fully capture how the object moves. For example, how far the object traveled, or how long the movement took, how fast the object moved, what time of the day the movement happened, which day of the week the movement occurred. All these factors can influence movement behavior. Therefore, additional columns have created from the original dataset to help the model better understand these patterns. First, I have created time difference feature. The first new feature, time difference column, calculate the difference between the start time and end time of the movement. This value represents how long the movement took. For example, if a movement started at 12 and ended at 12:10, the time difference would be 10 minutes. This information is useful because the duration of the movement often influence how far an object travels. A longer duration usually means a longer distance traveled. By including this feature, the model gained more context about the movement. Next one is the distance moved feature. The next feature created was distance moved. This column calculates the approximate distance between the starting and ending coordinate. The distance is calculated using the difference between latitude and longitude values. Although latitude and longitude represent geographic coordinate, calculating the distance between them give us an estimate of how far the object moved. This feature is very important because it helps the model understand the scale of movement. Without this feature, the model only sees coordinate but does not directly know how far the object traveled. Next is the speed feature. After calculating distance and time difference, another feature called speed was created. Speed is calculated by dividing the distance moved by the time taken. This feature represents how fast the object moved between two locations. Speed is an important indicator of movement behavior. For example, a slow speed might indicate walking movement, a higher speed might indicate vehicle movement. Including speed helps the model learn whether faster movement lead to different location pattern. Next one is the day of week feature. This column extracts the day of the week from the timestamp. Movement pattern often vary depending on the day. For example, on weekend people usually travel to workplaces or schools. On weekend movement pattern may involve shopping, leisure activities or travel. By including the day of the week, the model can learn pattern related to weekly behavior. Last one is the hour feature. Another feature extracted from the timestamp. This movement behavior often changes depending on the time of the day. For example, morning hour might involve commuting to work, afternoon hour might involve different travel activities, night hour might show less movement. Including this feature allow the model to understand daily movement patterns. After creating all these features, the next step was building a data pipeline. The pipeline begins with the original dataset. The dataset then passes through preparation stage where the new features are created. The output of this stage is processed dataset that contain both the original column and the newly engineered features. This prepared dataset is then used to train ML models. The advantage of using this Datagoo Cloud is that the entire workflow can be visualized as a pipeline, which makes it easy to understand how data flow from one stage to another. For predicting the future location, the machine learning models were trained. Since latitude and longitude are two separate numerical values, two regression models were created. One model predicts the future latitude and the other predict the future longitude. The algorithm used for this project is ridge regression, which is a type of linear regression model that includes regularization. Regularization helps prevent the model from overfitting the training data. During training, the model learns relationship between the input feature and the target coordinate. For example, the model learns how the starting location, time of the movement, speed, and other factors influence the final destination. Then we have model training and evaluation. The dataset were divided into training data and testing data. The training data was used to teach the model how different features influence movement. The testing data was used to evaluate how well the model performed on unseen data. To measure performance, the R square score was used. The R square score measures how closely the predicted values match the actual values. A value close to 1 indicates a strong relationship between predicted and the actual value. In this project, the model achieved a very high R square score, indicating that the prediction closely matched the actual movement pattern in the dataset. Once the model were trained, predictions were generated for each row in the dataset. For each movement record, the model predicts the next latitude and longitude based on the input features. The predicted latitude and longitude value represent the estimated future location. These predictions were stored in new column called predicted latitude end and prediction longitude end. Since the latitude and longitude prediction were generated separately, the results were combined into a single dataset. This was done by joining the prediction dataset using a common identifier. The resulting dataset contained both predicted coordinate. This dataset represents the final output of the prediction system. To visualize the predicted location, a geographic point column was created using the predicted latitude and longitude values. These coordinates were then plotted on a scatter map. Each point on the map represents a predicted future location. This visualization helps us easily observe movement pattern and predicted location gradually. So this is my entire pipeline which I have created for the future location prediction. First, this is my raw data set which contain all the columns which already provided ID, event time, start and latitude, start, end, longitude, start and end. Then in flow I have prepared this data set. Like here I have selected one name, then create recipe. From here I gave formula and then created my new column, new features like time, speed, distance, hour, daily, days of week. This way I have created. Then after creating this new prepared dataset got created, which contains all the day of the week, column, hour, distance, speed, time difference, all these features got created which will be required for prediction, which these are all the useful feature for prediction. Then after preparing this data set, I have trained this model. I have selected this, then lab a auto ML prediction. I have predicted for longitude. First I have did for latitude end, then quick prototype. From here I have created this. Now if I do train, the model will start training, and here my features got trained in two model. One is for random forest, another is ridge regression. I have chose the ridge regression because it is giving higher prediction. Its R2 score was high, that's why I have selected that model. Then I will go back. This way I have created these two prediction. One is predicted latitude, another is predicted longitude. Then after creating, I have checked the score. Here I have checked the score of the dataset. First I have selected that model, then I have built that model. This is a build. I have built these two model, then I have checked the score, then latitude in prediction and longitude in prediction, these two came. Here this prediction, when I am checking the score, this prediction got created. This is my original latitude in column, and this is my predicted column which the model predicted. Okay, for my this prediction, uh, ridge regression model is taking this latitude. I have created a feature called day of the week. It is taking this feature, except the original feature, it is taking this feature for latitude. And for longitude prediction, this ridge, it's taking the hour feature. Two model, it got trained on two model, random forest and ridge. I have took the ridge because its accuracy is high. R2 score accuracy is higher than the random forest. For latitude and for longitude, again this ridge have an accuracy of 1, which is higher than the random forest. So I have also taken this. There I have selected, and then I have deployed it. After the score, my latitude and prediction and longitude and prediction two got created. Then I have tried to join these two datasets. latitude prediction and longitude prediction into a single data set, but it is both have the same column name prediction. So I have again prepared to rename the prediction column to prediction latitude and prediction column of longitude to prediction long. Then I have applied join and I have created a final dataset which is future location prediction. Here in this dataset, both the column of prediction latitude and prediction longitude became. Now the prediction latitude end and prediction longitude end came into a single dataset. Then I have tried to create the visualization of this of the future prediction. This is the chart. These are all the future predicted point. I have to build for the geo point. I have to build again, prepare this future location prediction and make this prediction location geo point. I have to create this prediction location geo point. After that I was able I will after that I was able to create this geo map, this scattered plot. After creating this prediction location from predicted latitude and predicted longitude end. So this is my entire workflow, entire pipeline from raw dataset to future location prediction, visualization or the prediction point. In conclusion, this project demonstrates how machine learning can be used to predict future location based on historical movement data. Using Datacube Data Studio, a complete workflow was built that includes data preparation, feature engineering, model training, prediction generation, and geo point visualization. The additional feature created during data preparation help the model better understand movement behavior, which improve prediction accuracy. The final system successfully predict future geographic coordinate and visualize them on a map. In this project, we started with a dataset containing GPS coordinate and timestamp representing movement from one location to another. Since raw data alone is often not sufficient for machine learning model, several additional features were created during the data preparation stage. These include the movement. This engineered feature helped the model better understand the behavioral and temporal pattern of the movement. A complete data science workflow was designed using this Dataku Data Science Studio that included data preparation, model training, prediction, and visualization. Two regression models were trained using the ridge regression algorithm to separately predict the future latitude and longitude coordinate. These predictions were then combined to form the final predicted geographic location. The results showed that the model was able to learn the relationship between starting location movement characteristic and destination coordinate with high accuracy. Additionally, the predicted coordinates were visualized on a graphic map, which makes it easier to interpret the movement pattern and predicted location spatially. This project demonstrated how combining geopoint data with machine learning technique can provide useful insight to movement behavior. The main achievement of this project includes successfully preparing and transforming raw GPS movement data, creating meaningful features that improve model learning, training machine learning model to predict future coordinates, generating predicted latitude and longitude values, combining predicted output into a final dataset, visualizing predicted location using geopoint mapping. The approach used in this project has several practical applications in real-world scenarios such as vehicle route prediction in transportation system, delivery logistic optimization, ride-sharing movement prediction, smart city mobility analysis, tracking and predicting human movement pattern, improving traffic management system. Although the system performed well, there are some limitations. The dataset used in this project contain historical movement record, but in real-world system, additional factors such as traffic condition, road network. Overall, this project highlight how machine learning. So these are the key findings. The machine learning model got successfully trained and historical GPS data using historical GPS data for location prediction for future, higher accuracy predicting future geographic coordinate, and we have the visualization which confirm the ability to estimate movement trajectory effectively. This this is applicable for real world scenarios like tracking of vehicle, route prediction, etc. Through Dataku Data Science Studio, we were able to make our complete data pipeline from preparation to visualization, and also we have demonstrated I have demonstrated machine learning power in predicting future location from historical data, and the result confirmed the accuracy of movement pattern from the raw data. Thank you.